Hello students, welcome back. So now we are going to be learning about adjusted R square. Well, in our regression models, especially your linear regressions, we use R square concept. We use R square to measure how well or how good your model it explains the variation of your target variable. And this was the formula, this was the equation used to determine R square. In this case, your SS rest, that will be your sum of squared residuals, and your SS total, that would be this right here. This is called the total sum of square. But there is a problem with this R square. R square, it tells us what percentage of the variance in your target variable, that is your y, is explained by the model. For example, if your r square equal to 0.80, it tells you that this model explains 80% of the variance. Now, if you keep adding more features to your model, you will notice that your r square, it would never decrease. Your r square, either it increases or it stays the same. Well, why is that? Let's understand this through this equation right here. So this is the equation of my r square, and this is equal to 1 minus sum of squared residual divided by the total sum of squares. Now, suppose this is my original equation right here, from here to here. And this term is the one that I'm adding. So because I added this one term, so this is my new term now. So my SS total, which is my total sum of square, this is going to be summation of yi minus y mean whole square. Now, if you look at these terms, your yi and y mean, that does not change because of addition of this term. This term has no influence on your actual target variable and on your mean, on your average. So in this case, your SS total is going to be same. It will not change. On the other hand, this term, this is going to decrease because this term right here, this is your prediction, and your prediction is going to get better with the training set because now you have one additional extra term over here. So in this case, your SS residual, this is going to either decrease or is going to remain the same. So this term right here will actually decrease. When this term decreases, this whole term is going to increase. So by adding more features, your R square, either it increases or it stays the same. And this encourages your overfitting. And this is where your adjusted R, it comes in. The adjusted R square, what it does is that it corrects the R square by penalizing, by punishing the unnecessary predictors. In other words, unnecessary features. And this is the formula for your adjusted R square. In this case, your N, that is the number of observation, how many data points you have. P, that would be this one right here. This is the number of predictors, how many columns, how many features you have. And this R square right here, this is the regular R squared. Now, suppose I increase my number of predictors, my P goes up. Well, in that case, this term is going to go down. That will be this term right here. This term goes down. In that case, this term is going to go up. That would be this term. So this term is going to increase. Now, when this term increases, there are two cases related with this R square. Either my R is constant, in other words, my R square is constant, it did not change, or there was a significant increase in my R square. So let's take the first case first. Suppose my R square is constant, or there is a small increase in R but not a big one. In that case, my adjusted R square is going to decrease, and that's because this term is pretty much constant. And because this term is constant, and this term right here, this whole thing, this actually went up. And because this term went up, this whole expression is going to decrease. So this is your adjusted R square going down. On the other hand, the second scenario, if there is a significant increase in your R square, well, in that case, although this term right here, this term actually went up, but because this term actually went up significantly, this term actually went down. And this term actually dominates than this term. In other words, the decrease in this term is more than the increase in this. In other words, that would be this term is dominating. And because this term is dominating, this whole expression is going to go down. Now your expression went down, that means 1 minus this whole expression is going to go up. So your adjusted R square actually goes up. Now let's look at some of the key points of adjusted R square. The first one is this. It increases only if the new feature improves your model significantly. We just saw that in the previous slide. Also, it decreases if your new feature adds little or no value. Well, that's because your R square either is constant or it increases just slightly. So that's what this means. Also, it rewards good features and penalizes unnecessary features. So suppose this is my model right here. This was my original model up to here to here. And then I added this term right here. So If this is a good feature, it is not going to penalize it. It's going to reward that. On the other hand, if this one, X3, is a bad feature, it is going to penalize this model. So let's understand this through a simple example. Suppose I have two models, Model 1 and Model 2. Your Model 1 has two features, X1 and X2. Your Model 2 has five features. Let's say X1, X2, X3, X4, and X5. And let's say the R square value for the Model 1 with two features, it is 0.80. And the R square value for the Model 2 with five features is 0.85. You can see that your R square actually went up from 0.80 to 0.85 when the number of features actually went from 2 to 5. Now let's take a look at the adjusted R square. On the other hand, your adjusted R square, it actually went down. It was 0.78 over here, now it is 0.74. So even though your R square, it increased from 0.80 to 0.85, but your adjusted R square, it dropped from 0.78 to 0.74. So this means that the extra features that you added, let's say these are the extra features you added, these are useless. So when should you use adjusted R square? Well, you should use adjusted R square when you're comparing multiple regression models. Also, when you're performing feature selections. By using adjusted R square, you can determine which feature to use and which features to discard.